Okay, hello. I'm a bit late, I'm sorry, but I made it. My name is Kristofer Dovstam. I'm from Ericsson Research. I'm here in Barcelona this week for the Mobile World Congress. I'm working with one of our demos there. And I wanted to take this opportunity to come here to this meetup and present a little bit what we're doing with OpenWebRTC right now. And first, a reality check. And how many of you have heard of OpenWebRTC before? Okay, okay. It's good I'm here then to inform you a bit more. Okay. No. What am I doing? No.
Yeah,
That's good. Should be the other one. Okay. Okay, so what is OpenWebRTC? It's a mobile-first WebRTC client framework. And we have put quite a lot of effort to make this framework work as well as possible on mobile platforms. It's what we call a permissive open source. It's under the BSD2 class license. It's an independent, interoperable implementation. It's currently being integrated into WebKit. And during the development of OpenWebRTC, we have had very much in mind native applications, and especially native applications for mobile platforms. And it's available on GitHub, of course. And I'm very happy to announce that yesterday, actually, the data channel support was contributed to OpenWebRTC. And so what is the data channel? Well, the data channel gives us the possibility to send all kinds of data, and not only audio and video. And with the data channel, you can control the reliability and ordering properties depending on needs. Basically, it's the SCTP functionality. You also have the possibility to use encrypted real-time data. The OpenWebRTC implementation of the data channel is based on the reference SCTP implementation. It was contributed by Collabra. Thank you very much. And it has actually been tested and used in real time, in real use cases, which brings me to the main reason why I'm here this week in Barcelona. And I'll give you some background to that. A number of, no, that's not true. A little over a year ago, we came up with the idea of remote control over mobile networks. This is to showcase what kind of new applications that the next generation mobile networks can make real. And the project is remote controlling of an excavator from a long way away. We use WebRTC technology. We want to optimize solution for high performance and low latency. And a year ago, we demoed at the Mobile World Congress 2014 a toy excavator. You can see it here in the image. It's actually a small little toy and remote controlling of that excavator. It uses an earlier internal version of the OpenWebRTC. It has an iPhone for media capturing and the Oculus Rift DK1 for media rendering. And then on the side, there is signaling for the control of the actual excavator. But that's not included then in the WebRTC stuff. And this year, we took this project to a whole different level. We actually remote controlled real machinery. This is a wheel loader that we used in the north of Sweden. And we actually drove this using WebRTC. It was really interesting. Here's another example. It's a small excavator. I'm standing there controlling it, in this case, with a gamepad, but we're doing it differently, of course, from a further distance. This is a research collaboration with Volvo CE. And for those of you who thought that Volvo only makes cars, there's something called Volvo CE, which stands for Volvo Construction Equipment. They make a lot of these heavy machinery. They also think it's very important that I tell you that it's not a product, this thing. It's very much a prototype. So, the excavator then. All these heavy machinery was brought to us and given to us or lent to us by Volvo CE. And they have been modified to handle electrical control signals. Typically, especially these smaller excavators, they had the levers control the valves for the pneumatic directly, and so they had to be kind of modified to actually take electrical signals instead. And in this, we have a powerful Linux PC for the media handling, the media encoding, and so on. We used a Python application with custom signaling built on top of OpenWebRTC. Let me change this one here. And here, let's talk a little bit about the audio and video capturing. If you look at this thing here to the left and to the right, it looks a bit futuristic. This is actually built up of 3 different things. In the top, we have a 360-degree lens on this stick there with a tube under it. And below that, there is it's a high-end lens for focus and the ability to change the aperture. And below that, there is a small but very capable industrial camera. It has, in this particular camera, has a 2000 by 2000 resolution, and it is very low latency. When we started out with the first version of this project, we had a lot of problems with latency. You need really low latency to do this remote controlling, and we realized we can't use the iPhone, and we want to have we want better quality, better camera as well. So we started looking at consumer cameras, basically. I mean, for example, the GoPro is a very good camera. It has high resolution. It's great, but it's not made for real time. People put them on their helmets and they go skiing, and it works perfectly fine. But they don't need low latency. The GoPro, when we tried it out, it actually can buffer up to 5 frames before you get access to the image. It's called image acquisition. And I mean, if you have, let's say you have 50 frames per second, then that's like 100 milliseconds. It's too much for these kind of use cases. And the other weird thing there is actually the microphone array inside this big thing. It's made out of you take a lamp shade and you take away the cloth and you put the women's stocking on it. That's what it is, this black thing. So it's a protection from rain and so on. And there we have 4 microphones directed in different directions. So what about the other side? In the other side, we have this nice-looking control rig. It's the chair. It's the same kind of chair and levers and so on as it is in the real Volvo C machines. This one was made by Volvo C together with a small Swedish company called Oryx. They make these kind of simulation chairs for training and to educate drivers to drive these kind of machines. And they were also involved in this project. And they modified this simulator to, instead of doing simulation, you take the electrical signals from the levers and they made it possible to send it over the network. And then we have a Mac in this case on this side, and a Coca application with, again, with custom signaling built on top of OpenWebRTC. And what about the audio and video rendering? As I said, the first version of this project used the Oculus Rift DK1, which has quite low resolution. This year we're using the DK2. It is still too low resolution, unfortunately, but it's getting there. Hopefully the DK3 will be good enough. We'll see if there is one. As you saw before, we have the 360 lens, so we capture a donut. It looks like a donut, the thing that is captured, and that is converted then into a panorama texture and mapped to on a sphere. And then, because we do that, we can do local rendering, so which minimizes the motion to light latency of the head movements, which is very, very important, not to get motion sickness. So this really limits the puke artifacts, if you want to call them. And then we have a 4-channel audio renderer as 4 independent sound sources in a 3D space. So it's a 3D audio. In the simulator rig, we have the analog controls, as I said. And the computer there, that measures the analog signals, and it converts to digital signals. These control signals are then sent via WebRTC data channel to the excavator. We think this is it's an excellent application and usage of the data channel. The excavator then converts the digital signals into analog control signals, and voila, it's alive. Oh yeah, that is me. We had a lot of fun during this project. It was really cool, very different from what I usually do. And I don't think you can see that here. This is actually my colleague, Robert Swain. I don't know, maybe you've heard of him. He's kind enough to drive me around a bit in the excavator. I think I mentioned most of the things here. It's just a picture of the architecture. I can tell you that the audio and the 3D audio is actually really surprisingly important to be able to control the excavator well. It really adds to the presence when you sit with the Oculus Rift, and you get a very good audio also, so you can hear what you're doing. Victor asks for details, technical details, so I added this slide. I'm not going to go through all these things, but maybe you're interested. I can mention that when you do these things, remote controlling of these really heavy machinery, of course, safety is very important. It's very important to us. It's probably even more important to Volvo. They build very much of their brand on safety. We chose to implement, we can call it safety in this case, by when we send the signals to control the excavator, it needs to be a continuous stream, basically. If there is any interruption in the signals for the controls, the excavator stops right away. So it has, I don't remember exactly what it was, I think it's like 25 milliseconds of interruption, then it just stops. So that's how we handled that kind of safety in this application or prototype. I wanted to show you some pictures. We are showing this right now at the Mobile World Congress. It's a huge success. It's very fun. We are in this scenario. We have 2 excavators. One is outside our hall at the Mobile World Congress. I don't know if you're all there or maybe you've seen the excavator. And then we have another excavator in Sweden, a small town called Eskilstuna, which is 2,500 kilometers away from the mess hall, from the hall. And it's people are lining up to drive that excavator in Sweden. And I think it's very, very cool. So we're very happy about that. And it's been really fun to work with that. And it's going to be interesting to see what what will come out of this in the future. I had a video here I wanted to show you. I don't know if it works when we run it from the USB stick. I think it might be jerky. You could...
That one?
Yeah, exactly.
Only 437 meg.
Yeah. You could try it. It's not.
We got really excited and just started hacking away.
Seems to work.
We would teleport ourselves to another location.
It's only the speed of light that really limits what we can do in this area.
4G is now fully operational. At Ericsson, we're working on the next step. So what possibilities will future networks bring?
We got a request to look into what 5G could mean, or future networks, what that could mean from an end-user perspective. Then one night I found this new technology called the Oculus Rift virtual reality goggles. I thought that, well, these are made for gaming, but what if we could use them to stream live 360 video and use this as a viewport when you're remote controlling a vehicle, so you really get the feeling of being somewhere else. Basically, get the feeling of teleportation.
The team at Ericsson put together a demo consisting of a control rig with virtual reality goggles and 3D audio headphones. The control rig was then connected to an excavator with a 360 camera and microphones that streamed video and audio back to the control rig.
So with this use case, we really want to utilize current technologies and pushing them to the limits, as well as adding on new technologies.
So my team is doing research in the area of real-time communication. And the excavator project is really interesting for us because it forces us to really push the boundaries of what is physically possible in terms of really high performance and mobility.
We started out this project using a small toy excavator and an iPhone with a small little 360 lens attached to the iPhone. And now we have moved to the real thing, basically, with a much better camera solution and a real excavator.
We do it for real this time. We have improved the image quality. We have a higher resolution camera, and we have a lower latency for the transport of the image.
When you're dealing with the real stuff, you want to be able to do things with precision and have high safety. And then you need really low latency and very good quality. So we had to go to industrial cameras to find cameras with high resolution and low enough latency.
And everything is running over 4G, or the LTE network. So we're really improving the demonstrator. But to get even higher image quality and lower latency, we need to improve our technology even further. That's why the development of 5G is necessary.
The current demo is focusing on an excavator, but with future networks, the results can be applied to other areas.
Basically, we could look into other industries such as agriculture, mining, forestry, or transportation. So the possibilities for these kind of use cases are endless.
And since we have built the full application using our open source project OpenWebRTC, a lot of other people will also benefit from all the improvements and optimizations that we have done.
If you compare this to fully autonomous cars, I mean, we don't want to replace humans, but we want to place them in a safe environment. I mean, we have gas-filled mines and we have power plants that failed. People shouldn't be in those hazardous environments. If we can have a remote-controlled excavator, for instance, or a remote-controlled vehicle, and the human being 50 kilometers away, that's something for the future.
I think we're probably about out of time, but if anyone wants to grab Kristofer for a chat afterwards, they're welcome to. Victor, do you have any final comments, or I think we're going to close. There's the gentleman from UPF. Is it not going to? Okay. Right. Well, in that case, we actually are over. Thank you all so much for spending your Wednesday evening until 10 o'clock talking about WebRTC, and hope to catch up with most of you at various other events over the next few months. Cheers. Thank you.